name's Will Garner. I'm a design manager now for Midas, but 10 years ago I found myself in a fortunate position as a budding young architect working on this fantastic project as part of a bigger team at the architects Field & Clegg Bradley. And it's a real honour. I don't think anybody really knew or appreciated how special this project was going to be. So it's a real honour now, 10 years later, to be talking about it. Okay, is that better? Yep. Yeah. Yep. Some nods at the back. That's a good sign. So this is the structure of the presentation. I'm going to start at the beginning with some architectural drivers for innovation. And then Kai and Andrew are going to talk a little bit about the CLT and the structural proposals that we came up with as a team. And then I'm just going to wrap up at the end with a small presentation on the post-occupancy evaluation that the client undertook themselves, a self-initiated study. So, really, how did this journey start? And what we know is that every project starts with a brief. And every brief starts with a need, and in this particular case, the need of the neonatal department at the Royal United Hospital in Bath is demonstrated by these pictures here. You can see their old facilities were very cramped, very noisy, very dark, and increasingly unfit for purpose. You can see that the parents here. It doesn't work on the screen actually, but you can see that the parents there are in a very stressful environment, and we learned that premature babies really sort of are born as early as 24 weeks, which means that they're sort of 16 weeks early. That's 4 months. So for a lot of these parents, it's a very long period of time to go through. It's a long journey. And it's very stressful as a result. And the clients and their medical staff, their team, they knew that they had a great team around them. They had a great vision. They knew they could achieve great things, but their facilities were letting them down. So they started on the journey of preparing a brief for new facilities, and in that process of looking at other examples of healthcare projects or neonatal projects in the country, they found that a lot of the examples they looked at were very successful in ticking all the boxes from a technical compliancy perspective, from a process perspective, but they felt that none of these projects really delivered what they wanted to deliver, which was a very sort of humane, empathetic architecture. And they wanted to sort of rewrite the brief by putting the parents first rather than the technical processes or the medical facilities around them. So they came to Field & Clegg Bradley and quite interestingly deliberately chose Field & Clegg Bradley because we had absolutely zero healthcare experience running up to that date, which is a huge risk. It's a huge, when you're spending £4 million of someone's money to employ an architect with no previous experience, can be perceived as risky. But actually, it was a very deliberate decision because we as architects had no preconceived idea of what a healthcare neonatal unit should look like. We were able to very deliberately ask those challenging questions, those probing questions, and say, why does it have to be like this? And that was seen as a real positive for the project. Now, the first step, as you can imagine, was to develop the concept for the proposal, and it was working with the staff at the hospital that we learned a great deal about the journey of the premature babies from their birth in the maternity ward. Through a series of care rooms, really starting here with the most intensive care units for the babies who have the most critical conditions, the babies that are born the earliest. And eventually, as the babies grow stronger, and they become healthier, they move around the circle, this horseshoe floor plan, going from intensive care to high dependency to special care, eventually to the parents' rooms where they're allowed more one-on-one time with the parents, and then eventually out the door to their safety of home. And of course, at the centre of the floor plan is the staff base, where the medical staff have all the access and visibility of all the care rooms around it. So that's what really led to the floor plan that we can all see in front of us there. So this is the completed project as seen from the outside. Very small, very humble, very honest. But I think in terms of drivers for innovation, I think it was the site constraints. There's another determining factor in this project. You can see in the background there the existing Princess Anne Wing facilities, the old facilities. And when we looked at this site for the first time, we realised that obviously we're going to be building a new building in the immediate proximity of a live hospital environment with some care wards on the first floor overlooking this construction site. So we knew that we needed to come up with a proposal that was quick, that was quiet, didn't have the same sort of dust issues or the heavy groundwork issues that you would associate with more traditional forms of construction. And it just so happened that at the same time we'd finished another project called the Woodland Trust HQ, which was a 3-storey CLT project. So we were sort of, as a practice, we were learning a great deal about cross-laminated timber, and it just seemed right to propose it for this project. But it was really on the inside that the decision to use exposed cross-laminated timber really came into fore, because I remember when we first proposed this idea to the clinical teams, they absolutely loved it because it just spoke straight away of it aligned with their ambitions for their projects. They wanted something that was warm and natural, sustainable, organic. So this idea of exposed timber and a healthy environment just aligned perfectly with their expectations. The problem though, there's always a problem, and on this particular project we needed to get approval from their infection control teams, and infection control have the ultimate authority on the specification of new materials in these sorts of projects, because at the end of the day they're very concerned about the growth of bacteria and infection and the risks to the babies in this ward. So they were very sceptical at first, as you can understand. You know, timber is a hygroscopic material, so it moves and it expands and it contracts, and it has natural defects in it. And they were concerned about cracks in the timber and the opportunities really for bacteria to grow in those cracks. So we as architects became super interested in the sort of the surface characteristics of this timber. And we worked with the infection control team, we listened to their concerns, and we went back to the drawing board and we went back to the codes, and we couldn't find anything in the building codes that said you can use timber, but equally we couldn't find anything that said you can't. And so that in many respects gave us a bit more impetus to keep challenging, keep plugging away at this. And eventually what we did was we approached a company called Holman Paints in Swindon, who had used on previous jobs for a special seal that you have to apply to the surface of these timber structures. To comply with Part B building regulations, you need to provide a surface spread of flame treatment or a sealer to the timber to prevent the spread of flame in the event of a fire. And we used that opportunity to effectively create an impervious seal to the face of the timber. And with the help of Holman Paints, we were able to basically develop a product called Envirograph, which was flexible enough to move with the timber, and it effectively created an impervious seal to the face of the timber. And so we went back to infection control, lots of samples under our arms, and we finally managed to convince them to sign it off, which was great. The one compromise we had to make was, you can see the PVC white rock below 1400 mil, the wall cladding on the inside, and that was the one compromise we had to make, was that anything below 1400 mil had to have traditional standard healthcare materials, but everything above that we could do as we wished, and so we did. This is the staff base in the centre of the horseshoe floor plan that we saw before, and I think it's a great image that really demonstrates the qualities of light that we got into the space, the qualities of the exposed timber that we managed to get, the juxtaposition between the natural properties of the timber and the very sort of futuristic space age technical requirements of the healthcare project at the time. So really, this is the last slide for me now on this. There's a lot of the client was very interested in a humane architecture that placed babies and parents at the heart of everything that they did, and parents none more so. Very stressful time of their lives, and we managed to shoehorn in a small courtyard space in between the new building on the left and the existing facilities on the right, just enough to provide a small moment of reflection and calm, fresh air, just to relieve that stress for the parents. And the result of that was, as we'll come on to in the post-occupancy study at the end, parents were spending more time in the facilities, more time cot-side, and of course that can only be a good thing for the babies. So to summarise, really, the key drivers for innovation on this project were, in my opinion, the clients from the very beginning they wanted to have they had a very clear image in their minds of what they wanted to achieve with the project. They were bold in breaking new ground. The second driver was the design team that they employed. They employed a design team who were given a green light to do something completely out of kilter with typical projects of the time. And then the third innovator was the very unique site constraints that we found ourselves in, working in a live hospital environment with care facilities overlooking the site. And I think my colleagues, my friends Andrew and Kai from KLH and Bureau Happold are going to talk a bit more about the CLT as a structural solution and how they overcame those site constraints. So I'm going to hand over now, I think, if that's all right, to Andrew. Thank you.
Hi there. So Will's touched on some of these key issues that we needed to respond to, and if I started on the site, this is an aerial photograph of the site before any building and development had started. The Princess Anne wing down there to the south, a number of large mature trees on the site. It was also an area of existing services and also parts of linking corridor and infrastructure. Interestingly, my daughter was born during the construction of this, and I spent far too much time looking out of the window from the Princess Anne wing down onto the construction site, much to my wife's annoyance at the time. But that's the context of this. Very early on, we started exploring a structural response to that space planning, and initially we started thinking about steel frame was one of those options, but with timber infill panels. And the reason I chose this image, but it's very obvious and very clear here that this is a point load. The structural loads are coming down a steel frame at discrete points. Whilst the design is evolving, as responsible engineers, we were looking at ground conditions. What are we going to be founding this building on? And a couple of the key things which we established from our ground investigation was that there were large mature trees that had been cut down from the site, and the site was the underlying conditions were that of clay, a high plasticity clay that was susceptible to a large amount of shrinkage. Our concern with the approach of a structure that had point loads coming down on it was the movement of that clay shrinking under pad foundations and settling. We didn't want to put pile foundations in. It was costly, disruptive and noisy. And also the site had a lot of services distribution. Here's a services duct which ran across the site. So images here aren't great to explain this, but instead of looking at the concentrated point load foundations from a traditional frame, we looked at the ability to spread the load, so that instead of using pad foundations or needing to excavate down into that clay, we could have a raft foundation spreading the load of this building footprint evenly across the floor. So this is unfortunately, when I was going back through our records, this was the best. I couldn't find a photograph of the construction of the foundations, but this allowed us to put this flat raft across the site. It was a very quick thing to build. It was something which distributed the load across the site, and it's something which then was able to support this cross-laminated timber frame. Just like Field and Clegg, we'd recently completed a couple of cross-laminated timber buildings. This was 2009 when we were scheming this, and there was learning which we were able to take from that in developing this. The approach to fire protection, that of allowing the timber to char while still maintaining its structural integrity after 1 hour. And then we were fortunate, or we did have that experience of having designed clinical and hospital buildings prior to this, and we're able to bring a bit of the sort of technology understanding to these buildings. One of the key things with clinical buildings is the vast amount of services that go into those buildings. They're machines almost, these buildings. And while still trying to create that internal environment of the exposed timber, not cluttered by lots of pipes, wires, and everything else that goes with that, you'll have seen from the images which Will was showing, this box which runs along the top of that nurse base area through the spine of the building. So this is their suspended plant space, centrally able to distribute the services needed out to each of the spaces in a very efficient, effective way. So we end up with a structural timber box beam which runs across the top of the building, and then cellular structural spaces beneath for those clinical rooms that radiate around that central communal space. So that was in short term the structural response, and now over to KLH to look at how that went about implementation.
Thanks, Andrew. How are we going to go about this? Yeah. Collaboration, that's what seems to be the buzzword of the time at the moment. Early engagement, and in a way, I think, collaboration is something that is pretty much well known. It's probably just really a new word for, working together and pool resources to get a building done. There's nothing new about it. I think what is probably new about it is how it is done. And with cross-laminated timber, the processes of cross-laminated timber, or the fabrication of cross-laminated timber, is obviously having an effect on the procurement of the design as a procurement. And why is that? The cross-laminated timber panels are cut in the factory with CNC machines that respond to data-rich files that are generated wherever. And we in the office at KLH UK, we generated this 3D model in collaboration with Andrew and Will's team. So and we sequenced it. It's all these elements are the data rich. We can click on them. The model tells you how heavy they are, where they will be in the build sequence, on which lorry, and so forth. So that is, in a way, one of the key, I guess, innovations with regards to procurement. And I think when this was done, I think KLH was in its KLH UK was in its fifth year in the UK, and I think BIM was probably just about around the corner, but nobody really talked about BIM, whilst in a way we were already doing it. And what we do typically is we set up a program, like a design program initially, that we circulate within the team. We agree procedures, how long it will take us to build the 3D model, commenting periods, and so forth, and then how long it will take to go into manufacture. This is typically a 12-week process, and that didn't really change ever since. And what we produce is a set of fabrication drawings that you can. I mean, these are just two of those that indicate the panel thicknesses, the quality, visual grade quality of the cross-laminated timber. There are various visual grades that you can specify. There's a domestic visual grade, which is the highest grade, and I think that is what was specified in this instance, and non-visual grade, and so forth. So you can use the CLT just plainly structural, or you can expose it, and that is obviously a great feature of cross-laminated timber, which again I think almost like the reinvention of teamwork is a reinvention of a very old building material. In a way, it's just cross-laminated timber, and therefore engineered stronger. And obviously the manufacturing processes are very different. And here we can see how the each and every element is nested, as we call it, onto mother panels. So we've got the child panels on the mother panels, which in a way sort of work quite well with the theme of the project. And as I mentioned earlier, the data of the 3D model is fed into the CNC machines, and here we've got one of those at our factory in Austria, and these have tool heads that can be changed, and in the end of the day, off-site at the computer, we use these virtual tools to virtually cut the elements. All sorts of different types. These are 5-axis machines, so they can do really quite complicated cuts. And whilst the machines were doing their work, the turf was cut, and a few weeks later, we came to site with our first lorry. And obviously the interesting thing is that when you compare with other technologies, and you mentioned that earlier, that the number of deliveries is greatly reduced. You probably use 1/10 of the number of deliveries, because you can transport a lot of timber. So instead of 6 cubic meters of concrete in a mixer, you can bring it to site 40 cubic meters of cross-laminated timber in one delivery, and that obviously makes a huge difference. Also, obviously considering that the site was right next to an operating facility. And what we do as part of obviously our operation, we plan where to put the crane and how to actually build the thing. In this instance, we used a mobile crane, and this is how it looks in real life. In this instance, we brought the panels, dropped them onto the slab, let the lorry leave, and then started building. That's about 2.2 thousand square meters of cross-laminated timber, about 340 cubic meters on this side, and There's obviously a sustainability credential that you've got with building with timber. There's carbon stored, sequestered in the CLT, in this instance 79 tons, and obviously that is something that you need to consider when you're designing, so it's it's very sustainable. Obviously, I mean, here a few more images, and one of the great things as well of off-site manufacture is obviously that the services installation can be coordinated. Nowadays you do it with 3D services models that you then integrate to create a federated model. At that time, I think we weren't there yet, but what you can see is that there's a lot that's been pre-cut already, and that is obviously one of the great advantages to speed up the installation and also the follow-on trades on site. I think this is really me. I think Will, if you want to carry on.
Thanks, Kai. So this is the last section of the presentation now, and really there's so much credit that goes to these guys here, because this is the clinical team that led the post-occupancy evaluation study on the project, and it's really important to say that these were the experts in their field, and they carried out this study completely independently of any of us stood here today. So really, I'm stood here just as a representative presenting their findings, and we're going to talk about them and interpret them in our own way. But I think it's some of the outcomes that we're about to see are really interesting, because they sort of demonstrate empirically or scientifically what we all sort of know intuitively about building design in the form of light, sound, acoustics, and all the rest of it. So really, as a client team, they knew that they wanted to improve their environment. They knew that they wanted to measure. Being scientists, they wanted to measure everything. So they wanted to measure the improvement in their environment, and they started to ask themselves right at the outset of the project, what are the parameters by which we can quantify the quality of the environment. So they started to ask themselves questions about some very simple fundamentals, such as sound and acoustics. How does noise reverberate around a space, and what sort of effect does that have on the babies? Light, artificial light, natural light, the fluctuation between night and day, and also fundamentally, how much time do parents spend with their babies at the cot side? It sort of seems obvious, but to have the parents beside the cot is obviously can only be a good thing for the development of the babies. And of course, sleep as well. We all know how important sleep is. So the more time that babies spend sleeping, the stronger they get, the healthier they get. So these are all factors that they measured. And here's some of the outcomes really. So the first one is sound. They used LEQ sound levels using very standard sound measuring equipment dotted at various locations in both their existing facilities, their old facilities at the bottom there, and then when the project was completed, they repeated the same study in the new facilities at the top there. And we can see on this chart that here the sort of results of that study. So on the x-axis at the bottom, we've got a 24-hour clock, and on the y-axis vertically, we've got the measurement of sound in decibels. And I just think it's really interesting to see that in their old facilities, they were measuring on average sort of 65 dB across a 24-hour period. And that can be compared to the new facilities where they're sort of averaging about 58, which my basic arithmetic says there's about a 10% reduction there in noise in that space. So that's really interesting. And there was various aspects of the design that we implemented to help soften that noise, and we can talk more about that later. Light measurements. So again, using very simple light measuring technologies, they measured the levels of daylight in both their old facilities, which you can see here, dark and cramped, and contrasted with the new facilities here. So I guess we as architects and we as people know that daylight is good for you, it's healthy for you, and so we worked closely with the clinical team to develop a strategy whereby on the external facade you can see there lots of daylight coming in through picture windows and high-level clear story windows as well. And then in the central corridor spaces, lots of roof lights and these internal glazed screens as well, so that effectively we had daylight coming in from both aspects of the clinical spaces, something they didn't have in their previous facilities. So the results again sort of speak for themselves. What I find quite interesting about this is in their old facilities there was quite a fairly uniform distribution of light through a 24-hour period, whereas in the new facilities a marked increase in daylight in the middle of the day, and obviously that would tail off at night time. So the building felt more in tune with the natural cycles of day and night, and again the sort of feedback we were getting from the clinical teams was that this is a really positive thing for the health and development of these premature babies. It's interesting to think about the time that parents spend cot-side. This photo here shows their old facilities, and you can see how cramped it is. There's 2 families in that one space, and you could spend, worst case scenario, 4 months in that environment. It's stressful, and using very simple questionnaires and time measurement technologies, the team basically calculated that in the old facilities, again looking at the 24-hour clock on the x-axis, at the height of the visiting times, parents were spending on average sort of 25 minutes every hour beside the cot, and then you can see the curve would decrease towards the end of the day. We can only assume that was, for various reasons. I can imagine it was quite stressful, and that, your tiredness and fatigue levels would kick in. But it's nice, as an architect, it's really interesting to see how in the new facilities the change in the sort of in the behaviour of the parents, and the blue curve you can see towards the middle of the day and towards the afternoon, the visiting time was increasing to nearly 40 minutes every hour, and so I'm reading into that from an architect's perspective that parents felt calmer, more relaxed, and therefore more able to spend more time with their newborn babies. So again, a sort of a 50% increase in time spent cot-side. The clinical staff felt that measuring time parents spent at the cot-side was great, but it doesn't really describe the sort of qualitative contact time with babies. And they were telling us that a key contributor to the development of these babies was the actual skin-to-skin time, the actual touch time that they have with their parents, and a very important part of developing that bond between baby and parent. And you can appreciate in these old facilities, how difficult and imposing that would have been for a lot of parents to reveal skin for that very important part of development. And so they use this as a very deliberate measurement, and again found these results. I find it quite interesting how the curves are very similar to cot time and skin to skin time, again showing a similar pattern whereby in the old facilities parents were tailing off towards the afternoon, whereas in the new facilities parents were spending more time with skin to skin care. So again, as an architect, very, very, very heartwarming to see these results really measured scientifically like this. And then one last slide was the average time that babies were spent asleep. We know that sleep is so critical for health and development. And I think what this slide shows, there's two things I take from this slide. One is that babies have a very erratic sleep pattern, as a lot of parents will testify to. So again, a 24-hour clock on the x-axis, on the y-axis, you can see how babies are sort of fluctuating on roughly hourly cycles between 45 minutes in the middle of the night asleep per hour, down to sort of 35 minutes per hour in their old facilities, but how the blue line tracks these sleeping patterns in their new facilities, and we can have a discussion about how and why that came to be. But you know, from my personal perspective, I take a lot of warmth from these sorts of images because it demonstrates that the babies were sleeping more, and we can talk about whether that was down to acoustics, whether that was down to space, whether that was down to the attendance of their parents cotside, everybody feeling more relaxed and calm. But it's an interesting conversation to have, really, on the back of these results. So that's it for me, really. I think just to summarise, I think what I find interesting about this study carried out by the staff as an architect was that it sort of demonstrates scientifically what we all know intuitively, which is that just doing the simple things right, focusing on the simple things, light, air, natural materials, sound, and a calming environment, and it really does have a positive effect on the health and well-being of these spaces. So that's something that I'll certainly take away from this project. So yeah, thank you, Rupert. Over to you. Thank you.
Just working. That's fantastic. So really appreciate that. So I'm just going to invite the three speakers to come up and just take a seat, and then we're going to have a discussion. Glad to see there's already one question there, so that's great. So yeah, do get ready to join in and participate. Do all your microphones work? All right?
Is that working?
Yeah, they're working. That's great. I've got 5 children, which not necessarily very wise, but but so having actually been in a hospital on 5 occasions, I can relate. In fact, it's kind of bringing back a lot of memories. One of which actually was our first child. Took 24 hours before anything happened, and I found myself surveying all the fire doors, much to my wife's irritation, if it's any consolation, Andrew. So but you have to find something to do, and there's not much else. So yeah, I think I listened to a really great talk the other day, and it was an architect from DRMM who had designed at the other end of life a home up in Lancashire somewhere for oh, help me with a word, you know, when somebody's dying from cancer. Yeah, hospice. And he put some photographs up, and there were sort of photographs of, you know, how we typically sort of design a hospital, and a photograph of how they designed this hospice care centre up in Lancashire. And I hope you feel the same as you look at those photos. I mean, we need to ask ourselves, why do we build hospitals looking like this when they could look like this? The hospital that 4 of my children were born in, I won't mention which one it is, but I found one of those kind of scales, you know, just like a school leagues table. It was a hospital leagues table, and this particular hospital is about 242nd out of 244 hospitals in the UK, and I can testify that it deserved that ranking. It was an appalling place. On one occasion, my wife had a cesarean, and so she and my newborn son had to stay in Skaboo, it was called, and they were there several days. And in the end, I had to go in and rescue them and get them out because my wife was in such a state of sort of anxiety because she couldn't sleep. And anybody after about 2 days of not sleeping just kind of starts to lose the plot, and my son wasn't faring well. And I had to just extricate them and get them home. And it begs the question, well, if you can design a hospital like that and people sleep, well, like what? So why don't we design hospitals? I mean, sleeping is so fundamental for people who've just done something very tiring, like give birth, that you'd think it would be number one on the list. Anyway, those are just my thoughts. It's just kind of reminding me of a few things that I'd forgotten, and now it's bringing them all back to the surface. But what I want to do is encourage you to just ask some questions. So we're particularly thinking about doing things a bit differently, or a lot differently, pioneering, pushing out some boundaries, and hopefully this has given you some thoughts and some ideas for some questions. So the gentleman here, if you wouldn't mind, just say who you are and where you're from, and we'll put it to the panel.
Right, can you hear me?
Yeah.
Yeah. My name's Gerald Linder. I'm from the Netherlands, Amsterdam. I'm a great fan of CLT, so compliments for your building. But I'm here to learn, so I'm going to ask you some really critical questions. Actually, one, and regarding the air quality. So I'm very curious if a client actually measured the air quality. And the reason why I'm asking this is because CLT has, of course, glue in it. We talk about VOCs, but also people forget it's a natural material, so it has also radon. I see you're nodding yes, but that's why I asked the question. Thank you.
Okay. Kai, do you want to start us off?
Yeah. Can you hear me?
Yeah.
Okay. I'm not quite sure if I fully understood the question, but I think that it was about air tightness.
VOCs.
Air quality.
VOCs,
oh, air
yeah.
quality.
VOCs, for volatile organic compounds. And
The glue in the CLT is a PUR glue. It literally has unmeasurable VOC content, and that's been certified and tested. So if you want me to send you the documentation, I'd be more than happy to send this over to you. It can the CLT can be recycled like any other timber. So whether it's solid timber or CLT, it doesn't make a difference.
Just before we do that, am I right in saying I've been told that there are lots of different volatile organic compounds, dozens, or I don't know, maybe even scores or hundreds, and they're not all bad, are they? The trouble is they get given this 3-letter acronym VOC, but I mean untreated wood has VOCs that come off it, so they're not all bad. Some of them are just natural occurring.
Well, I can only obviously timber in itself contains substances.
Yeah.
Well,
Well, it's
they're
organic,
natural,
isn't
whether
it?
it's
Yeah.
whether it's resins or formaldehyde is that nobody really knows that, but obviously there's formaldehyde in timber.
Yeah.
But it is not in a magnitude that affects health negatively.
Yeah.
And that's been certified.
So we're, on this project, so no measurement of VOCs was.
No, that's right. It was a good question actually, because it made me think, and I mean, looking through the data that the clinical staff developed towards the end, I don't recall a conversation about the air quality, which is interesting. But I do recall conversations about specification of paint with low VOCs, and certainly the EnviroGraph spread of flame treatment that we put on the surface of the timber. We had to make sure that had a low VOC content as well. So there was consideration of air quality, but I don't think the medical staff felt it important enough to measure as part of their study.
Yeah.
I might be wrong on that, but that's...
So, yes, I mean, a worthy post-occupancy evaluation thing to measure, but I do think it's worth bearing two things in mind. One I've just said, which is, well, everything gives off VOCs. So it's not a question of does it or does it not. It's a question of is it a lot worse or a lot better than what we normally have. So, I mean, we're just sitting here and there's stuff giving off VOCs. I do remember being at a conference where somebody who had a service of coming in and measuring VOCs came in, and by the time we'd all sat there for about 5 or 6 hours, generally, sorry to raise this, but people's body odour and deodorant was frankly dwarfing whatever might have come off the chairs or anything else. So it's a case of understanding the relative contribution of these things. And then you mentioned something else, which was radon. No. Okay. All right. So another question from anybody else. Yeah, if you wouldn't mind just take the mic and give us your name and where you're from.
Hello, I'm Steve Pepper. I'm from Toronto, Canada. I have 2 questions. On CLT and timber construction, I'm curious what you've seen in terms of costs. We've seen contractors quote premiums for it over conventional techniques, and that's resulted in some projects being uneconomic using that design. So that's kind of the first one. I'm confused as to why it should cost more, given all the savings and foundational savings and the lightness and all that, and off-site and efficiency. I'm just, your perspective on that would be interesting. The second is, I'm wondering, we've seen local building councils and fire marshals have a reticence to approve these structures based on fundamental ignorance of the fire performance. And I'm just curious as to, to some insisting on having gypsum rock cover the timber, which, removes a lot of the aesthetic value. So I'm just curious if your comments and experience in that respect.
Okay. Andrew, you want to start us off?
I was going to start just from a designer's perspective on the cost side of things. There's a familiarity issue, I think, there with cost, particularly through the costing profession within the UK. As designers and as an engineer, I'm always having to explain the holistic cost landscape for introducing timber to a project, in that you cannot do a component by component comparison. You won't always be in the right place as far as an outturn cost comparison, but you have to be bringing into effect the issues of lighter foundations, the faster construction period, the lower prelims and time on site, and when you start looking at the whole thing, I've not done a detailed study on an option for a building where we've not demonstrated that the timber solution is the cheaper solution. So it's the willingness of the cost profession to work with you into and getting under the skin of what the whole impact of using timber will be, as opposed to the component by component comparison of a timber plank, a timber piece of CLT against a precast concrete plank. That's a very naive, simplistic way of doing that modelling.
We've certainly had the same problem, haven't we, in the UK, which is, as you say, a component by component basis. The trouble is you get your spons, or I don't know what the equivalent is in Canada, and it's got all these kind of individual items, and it all gets lost sort of between the cracks, because the savings are between the cracks, they're not the items themselves. And it does seem to take a long time to work with cost consultants. They sort of, it's a bit chicken and egg. They have to sort of see an actual project, realize that all those services, I mean, the actual savings in services must be phenomenal, because just putting self-tapping screws straight into timber versus having to pre-drill and put a roll plug in is phenomenal. Never mind the noise it makes and the people who are not sleeping whilst it's going on. And I think I don't know if you want to say any more, because the thing is, it is about collaborating with the QS involved and the client. The client has to kind of want it, don't they? And this is something that it seems is so crucial here, because I know, talking to you beforehand, the client wanted this project, and if the client doesn't want it, then it seems to always get lost somewhere along the way. So,
I mean, the client obviously needs to want it, but the client also needs to be able to afford it. And I think that some of the distortion that is happening is, caused by a lack of early engagement, and that is what we, always encourage people to do, rather than just drawing up a cost plan by themselves without, speaking with us. Just come speak with us. We have. Well, this is a service that we offer. We provide budget costs and program advice at very early stage into the project, and I think that is a fundamental thing that should not be forgotten and should definitely be considered.
I think it all comes down to the appetite for risk on behalf of the whole team, from the client through to the costing consultant to the members of the design team. If everybody is brave and everybody is prepared to do things a little bit differently and to spend the time overcoming the challenges, then projects like this demonstrate that you can do things differently. But I think the problem is that we all live in a very fast-paced world where answers and solutions are required tomorrow, and anything out of the ordinary takes more time. And I think that's the problem that we have. And I used to work as an architect, now I'm a design manager. I work with contractors and I work with estimators, and I'm proposing CLT for a lot of projects, and I get a lot of kickback all the time from the estimating department, simply for the reasons that Andrew just described, is that the costing consultants, they have a very black and white approach on how they cost these jobs, and it's very difficult for them to quantify all these holistic savings that the material offers. And the only way that they can get over this hurdle is by spending more time on the project, and in a very commercially driven world, it's very difficult for them to justify that time. I don't know what the answer is, but it's, I guess, collaboration, putting your arms around them and helping them through that process is probably the way forwards, but it's difficult.
Just maybe return to that topic again, but your second point was effectively about codes in Canada and accepting CLT. You're probably aware, in Britain, our building regulations are much more functionally driven rather than code driven. So it's not so much sort of deemed to satisfy route, it's you just have to prove that you achieve the end desired and required functional goals. Getting people out in the event of a fire, making sure that condensation's not a problem and so on. I do know in Canada that work funded by is it Woodworks, and you've got one or two key Canadian wood promotion organisations, they funded a load of work to produce a CLT guide, which I believe has been adopted and accepted by different provinces in Canada, Ontario, Quebec and so on. So it's all there, up to sort of maybe 4 or 5 stories high. So it exists, and I know it was a monumental task to get it, so that doesn't mean that you can get it through, but I don't know whether presumably you've come across that, have you, or not, or... Yeah.
We see there's still a reticence at the local level. Again, lack of familiarity with the local building departments. Lack of familiarity with the local fire marshals that see this as pyres, as opposed to the engineered carbon fiber, natural carbon fiber material that it is.
Yeah. So. Okay. Any other questions? Here we go. A question at the back. Again, if you just say who you are and where you're from.
Philip Lucas from Germany. The restrictions when it comes to building with CLT in Germany and Austria are far more restrictive than they are in the UK. I see, therefore UK is a innovative hub when it comes to construction with CLT, but still most producers of CLT are from Austria and from Germany, such as KLH, and they produce in Austria. So I was wondering, Brexit coming, what are the strategies for these Austrian and German producers? Are you planning to produce in the UK in the future, since it's such an important market for your business?
Kai, you're probably best.
I guess this is
placed
one
to-
for me. Well, I think it's an interesting question because I think if we knew what was going to happen after or Brexit, then I think we'd probably be able to earn a lot of money. But no, we are not intending to produce in the UK. We don't really expect drastic changes, and that is probably relatively optimistic approach to what's been going on so far. The market is not large enough at the moment to justify a production.
Okay, well, so essentially it's a business decision. It's about volumes and whether the volumes in the market are big enough to justify investment. There are, well, a good couple of firms, if not more, who have invested, although there are different sorts of, they're quite different companies. But it's like anything, that the market has to sort of grow, and then it gets to a certain point, and then things which weren't possible become commercially possible. Kai works for KLH. You've a particular business model that you're
I
working
guess
to.
I think this is me speaking today. Things can change, obviously, but this is, I guess, the current. Looking at the current market and also potentially, I guess, general risks involved. I think there's no intention to invest. I mean, we're building another factory actually in Austria at the moment, so we'll be doubling our capacity in about sort of 1.5 years' time.
And actually, European capacity for CLT is a very important point, isn't it? Because we had reached a point where the demand was kind of outstripping supply up until fairly recently, wasn't it? So it's important that overall supply does grow. So, well, I would just like to thank our three speakers. Perhaps you can just join me in giving them your appreciation. So thanks ever so much for that, gents. That's great.